Alright guys, welcome to part 2. Thanks for being understanding and watching this second part since, that phone call and stuff. So this chart kind of looks a little crazy, but I promise we'll get through it. Some pieces, for now, I'm going to tell you just to kind of go with the flow and believe me, and we're going to go into more detail in a couple, we're going to go into a little bit more detail in a couple lessons after this. So it's not terribly vital important to explain every single step, which is why we're because I know I'm going to talk about it in like 4 days, 4 videos at least from now. So we're going to go through part of it. Other parts will make more sense when we get there. All right, let's talk about point A. Point A was that very first point on my circle in the slide below 4, and the point was physical coordinate point was 1, 0. But you don't see that in here. Our coordinate points here, my 1, 0, 0, 1, I sound like I'm talking like a computer, -1/2, √3/2, those are actually trig function answers. What? Blowing your mind. These coordinate points that like point A that I wrote in black, are a version of sine and cosine. One is sine, one is cosine. My coordinate points here, and I'm going to scroll down because I'm running out of room. You have a little bit of space off to the side or above since you have that extra nice little space. Oh, come on. You have those headings that I give up there. Your coordinate points goes sine. Oh, backwards. Hold on. I'm reading off my sheet, the top of my sheet where it says sine, cosine. They go cosine, comma, sine. So in my point A of 1, 0, my cosine is going to be 1, and my sine is going to be 0. So they look backwards. Sine is the more prominently used of the two. We refer usually to just sine on most cases. So it goes goes cosine, then sine. I wanted to put them all together. So what's some of my other points that I had? Point B was √3/2². C was 0, 1. D was -1/2 √3/2. Point E was -1, 0. F was my first 45-degree version angle. It wasn't actually 45 degrees, but it was an addition of 45 degrees. Point G was another main 4. It was 0, -1. And H is 1/2, -√3/2. So those parts weren't actually too bad. All we had to do was take a look at what my points were, figure out which one goes where. The rest of this right side of the chart I'm going to give you, we are going to determine the left side together. So we're going to actually determine the left side. I'm going to give you the right side. So my tangent for point A is going to be 0. CSC stands for cosecant. I'm going to scroll it down so we get used to saying that. Just like we got used to sine, cosine, tangent, even though they don't exactly look like the spelling. Remember, it's short. Stands for cosecant. SEC is not secant. We're not in science class right now, because it's followed by a theta, which is a version of angles. Is pronounced secant. And my COT is cotangent. Again, we'll work a little bit more with this stuff in the next few days, but keep what we're doing now in your head for when we get there, because we will use this stuff then. So my tangent is 0, my cosecant is undefined or does not exist, my secant is 1, and my cotangent is also undefined or does not exist. D and E does not exist. You know, Mean Girls, the limit does not exist. My tangent is √3 over 3 for point B. Cosecant is 2. Secant is 2 √3 over 3. And my cotangent is the square root of 3. For point C, my tangent does not exist. Cosecant is 1. Secant does not exist. And my cotangent is 0. Tangent for point D is negative square root of 3. Cosecant is 2 √3 over 3. My secant is negative 2. And my cotangent is negative √3 over 2. Point E, my tangent is 0. My cosecant does not exist. My secant is negative 1, and my cotangent does not exist. My point F, my tangent is 1. My cosecant is negative square root of 2. My secant is negative square root of 2. And my cotangent is 1. G, tangent does not exist. Cosecant is negative 1. Secant does not exist. And my cotangent is 0. And last one, point H. I've got negative √3, negative 2 √3 over 3, 2, and negative √3 over 3. Woo! Got a good old majority of that chunk done. Now let's go ahead and figure out my degrees and my radians. Well, point A was located where? 0 or 360. Because we know if we go all the way around, still in the same spot. So I have 0/360. Point B we discovered was 30. C turned out to be a 90-degree angle. It's one of my main 4. D we discovered was 120 degrees. We determined that by basic addition. Point E is 180. It's another basic 4, or main 4. Point F was the first 45-degree version, and that was 225. G was a basic 4. It's 270. And H, we worked on that last one together. We determined was 300 degrees. Now the radian measure. This one's fun. I like doing these because if you're ever unsure, you can always just do some math and figure it out. Now, we determined these degree values by finding a starting point. Oh, I went the wrong way. Sorry about that. By finding a starting point and essentially adding. So if this is 0 degrees, 90 plus 90 is 90 degrees. Plus another 90 is 180. Plus another 90 is 270. And back around, we get to 360. We have 30, 60, 90, 120, 50, 180, so on and so forth. We're just going around in a circle and adding them. They have to be equal parts. They're in the same locations. Same idea with my radian measure. Well, if we don't go anywhere, we're still going to be at a whopping 0. But if we go all the way around, we talked about how our circumference was 2 pi. All right, 30 degrees. When we split 30 degrees, when we determined 30 degrees, we split our circle into how many different pieces? $12, that's the magical number I was looking for. We split it into 12. So to determine a piece, I guess I didn't write off to one side like I was planning to. Make columns on yours. It's a little bit easier. I'll try and do that when I do it on the board. For point B, that was a 30-degree angle. We split it into 12 pieces. So to find what a piece is, I have my whole value. Well, if my whole circle is 2 pi, because we're dealing in radians, it doesn't make sense to do degrees and radians at the same time. It's like trying to talk about, I have a really bad analogy in my head. It's like trying to talk about football and soccer at the same time because they can both be called football. No, not a good, yeah, see, it's the only thing I can come up with. If you're talking about football, stay with football. If you're talking about soccer, stay with soccer. They don't have the same plays. They don't have the same athletes. I almost said characters for some reason. I've been reading a lot. So we stick with the same type of whatever it is. It's degrees, so we're sticking with degrees. If it's radians, we're sticking with radians. Trying to find radian measure, so I'm going to stay with the whole amount of radians. So on top we have the total. And we're going to do our however many split parts we did. So in this case, we'd had 12. Oh, I wanted to write an S, not make that bigger. Okay, so that gives me the fraction of 2 pi over 12. Can I reduce 2 and 12 at all? Do they have any number in common that can be divided out? Please say yes. Good, I can divide both by 2. What is 2 divided by 2? 1. It's 1 times pi. So if you see pi by itself, there's an invisible 1. 12 divided by 2 is 6. So that first version, that first radian measure is pi over 6. I didn't give myself enough space or the right color. Now, I want to skip the 90 for a second, and we're going to go to the 120. I need to go back to my writing space. Okay. 120 is still technically a variation of this guy. How many 30 degrees essentially did it take me to get to 120? 1, 30, 60, 90, 120. So it took me 4 times to get to my 120 spot. So essentially, I could take this with my pi over 6 and add 4 of them together, or I could just go ahead and multiply that by a value of 4. And we know that there's an invisible 1 on the bottom. 4 times pi. Actually, right over here. 4 times pi is 4 pi. 6 times 1 is 6. Well, I can reduce down 4 over 6. I can divide both by 2. So I get 2 pi over 3. It's like saying 2/3, because we are 2/3 of the way there. If you look at it. If we're talking about only just the top part, I can't really cover it up on the thing. But if you only look at 180 degrees, we are 2/3 of the way there. So this value for 120 is 2 pi over 3. Next point I want to talk about is point H, because that was also another 30, 60, 90 part. There's also my guy down here. So if it took me 4 times to get to that guy, how many times did it give me to get to H? Well, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to take this times 10 this time. So I'm going to start with my original pi over 6, because that's originally how much each section is, times 10. So I get 10 pi over 6. 10 and 6 can both be divided by 2, so I get 5 pi over 3. So I have one more section until I get to 6 over 6, or 6 over 3, which is 2, which would give me 2 pi. So this last one is 5 pi over 3. Now, technically, you're probably saying, well, we counted the 90 degrees when we went around the circle, but we didn't do the thing yet. Why not? Well, because it's gonna, when you deal with the main 4, you're just gonna go ahead and divide everything by 4, because it makes life a little bit easier instead of having to count all those. Unfortunately, with the 30, 60, 90s, you have to count all of those. It's not as fun. So I wanted to show you the easier way with the main 4, since you'll be working with the main 4 more often. So let's talk about that 90, the 80, the 180, excuse me, and the 270. So again, we have my total of 2 pi. We split our main 4 into, good, which tells me that that can reduce down to a half, for pi over 2. So this first one is pi over 2. Okay, next one's 180. What is a half plus a half? 1. Okay, well in this case it's not just 1, but it's going to be a value of pi. So that's why you might have seen this before in looking at when you did the SAT and stuff. 180 is the same as pi. And then if I have 1, 2, 3 of them, it's going to be 3 pi over 2. We like those because you can just add them, basically, and put the number there. Because we know that 2 over 2 is just plain old 1, or a half plus a half. And lastly, my 45 guys. So I had, again, oops, too many. 2 pi divided by my 45s. Well, how many different 45s did I have? Well, I split it into 8 parts. And I can reduce that down to pi over 4. So the first 45-degree angle, if I go back a moment, that first 45-degree angle located, I'm going to use a different color so you can clearly see it, is right here. But we didn't have that as a point. We need to go all the way down there. So I have 1, 2, 3, 4, 5. And since 5 is not divisible by 4, it's just 5 pi over 4. So this looks like a lot of information, and I am aware of that. The hardest things that we did today. Some trig from last year. Basic counting. Basic multiplication. Division. That's it. We can count to 5 and 6 and 10. I think a base number was 10. We can divide 2 by random pieces and make them into other fractions. We can split our circle evenly and create triangles. We can determine the sides of our triangles using either 45, 45, 90 or 30, 60, 90. We did division. We plugged things in and multiplied. We plugged things in and subtracted by 0. We can do this. All right, your homework is that big project. If you don't know what it is, come see me.